Welcome everyone. In this video lecture, we will solve a GATE 2019 question in which we will find the average value of the output voltage in a diode resistor based circuit. So this one is a question. So in a circuit shown below, Vs is a square wave of period t, okay, in which the upper or maximum and minimum value of the voltage is 8 volt and minus 10 volt, okay, and it have a period of t, okay, and the corresponding circuit is this. We are having Vs as an input, one diode is there, and the diode is the ideal one, and one resistor, and another resistor is R2, okay, and the value of R1 R2 is given 50 ohm. The R1 R2 value is given 50 ohm. So now we have to find the average value of the VL. So first of all, we have to find the output waveform. If we draw the output waveform for the particular circuit, then we can say, or we can find out the value of average one. So first we will go for the output waveform. Okay. So first what we are doing, I'm just taking this. Okay, wait. I'm just taking this as a main circuit. Just I am copying this circuit. So now we have to just consider there will be two cases. Okay. So first I am considering case 1 when the time is in between 0 to t by 2. Okay. So in between 0 to t by 2, okay, the voltage will be plus 8 volt. So what I am doing, instead of this source, we can make a supply like this, okay, 8 volt. Okay, we are just making like this, 8 volt is there, okay, for the first half, for the first positive half, okay, in between 0 to t by 2, the value of vs is 8 volt. So we can write like this, 8 volt. So now we have to think, during the interval 0 to t by 2, the diode, this diode will become what? Off, because this diode will become in reverse bias. Okay, for the reverse bias I am writing RB. Okay, so for this case 1, we are saying there will be two case. Okay, case 1 when this one, okay, so t by 2, 0 to t by 2, okay, 0 to t by 2, the value of Vs will be 8 volt, so I am setting 8 volt. So during that time, the diode will be in reverse bias. So diode is in reverse bias. Okay. So diode is reverse bias means the diode is open circuited, or open circuited diode. Okay. So we can again redraw the circuit, the same circuit we are going to again redraw the circuit. Okay. In which what we can do, this should be our same, this should be our, okay, this should be our 8 volt, and this will be open circuited, diode will be open circuited, open circuited. Okay, so now we have to find the VL. So the current will go from like this. Okay, so we have to find the VL. So this is just simple circuit. in which we can say this looks like a very simple circuit like R1, R2, and we are just giving some voltage, okay, say 8 volt voltage, and we are taking output across this side. That is our VL for the time interval, okay. So by applying the voltage division rule, we can simply write the VL value will be 8 volt into R2 by R1 plus R2. We can also use some Kirchhoff's voltage law for this thing, but directly we can write this VL will be R2 into 8 volt into R2 by R1 plus R2. Okay, so 8 R2 is given, R2 value is given 50 ohm, both are 50 ohm. So 50 plus 50 means 100. So the VL value will be 8 into 50 into 100. So it should be 2, so 4 volt. So during VL, this VL value for the time interval 0 to T by 2, the VL value, output value will be, okay, the output value will be 4 volt. The VL value will be 4 volt. So we can say for this 8 volt, the output value will be simply, I'm saying this one is a 4 volt VL with respect to time for the interval 0 to T by 2, because first we are thinking about this interval 0 to T by 2. So this one is the output, okay. Now in the next phase we have to go for the case 2, okay. So what we can do, yeah, we can write case 2, okay. When the time interval, we have to think now for T by 2 to T, okay. T by 2 to T, what should be the Vs value? For T by 2 to T, the value of Vs will be minus 10 volt. So we have to just simply write minus 10 volt, okay. So now we have to find VL for this, okay. So again what we are doing, we are just redrawing the circuit. So instead of this Vs for the interval, it should be our minus 10 volt. So one can write like this, minus 10 volt, okay. And during that time this diode become forward bias, forward bias, okay. So I'm just highlighting this one. This one is our case 2, okay. Take some light color a little bit. Case 2 for the time interval this, okay. So this will be short circuited. Forward bias means it's short circuited, ideal one. So again we are going step by step. So what we can do, instead of this and this, okay, this should be our minus 10 volt, and this is also connected, okay. So the equivalent circuit will be like this, because it will follow the less resistance path. So there is no role of this R2, okay. So this should be our R2 plus of minus VL, and it is nothing but simply minus 10 volt. So what should be the value? So if we apply KVL in this loop, we can write minus 10 volt minus VL equals to 0. So VL equals to minus 10 volt. So same output will appear across this one. So VL value will be minus 10 volt, okay. So in that way we can say the output response VL in between T by 2 to T. Okay, T by 2 to T, its value will be, okay, this would be around minus 10 volt. So in between T by 2 to T. Okay, so minus 10 volt. So if we club the both the output, okay, so the overall output response, so the overall output response for that circuit will be very simple. You just see, for the 0 to T by 2, it should be 4 volt, 4 volt, okay, and for the next half should be 10 volt. Just combining both, we are going step by step. Okay, so this should be 0, T by 2, and T. This should be our 4 volt, it should be our minus 10 volt, if you want. Okay, so now this one is nothing but simply our VL as a function of T. Okay, so now this one is the output response of the circuit. Okay, means what we have observed that, wait, for a minute. Okay, means this one is the output, our main core of the circuit is this one. Okay, we are getting this as a output. Okay, and we are giving input like this. Yes, I am just copying this as a, means we are giving this as a input, we are getting this as a output. Okay, so now we have to find the value of the average value of VL, average value of VL. Okay, average value of VL. So for average value of VL, what we have to do, we have to take the area enclosed. Okay, this area enclosed, okay, area under this, we can say the area under this shaded region divided by the period of the output. So I'm just writing this area under the shaded region divided by the period of the signal. So it should be our area. So I'm just doing the area for this one. So if you have to find this area, so this kind of thing is there. So this height is 4 volt, 0 to 4, and this is T by 2. So this was just somehow rectangle type. So 4 into T by 2 we can write, or simply we can write 4 into T by 2 minus 0 for this half. Okay, clear? Plus minus 10 into T minus T by 2, minus 10 T minus T by 2 divided by the whole area, that period of the cycle, that is our T. So now we can say this should be our 2T minus T by 2, and this should be our minus T by T minus T by 2, and with 2 is there, so it should be T minus T by 2. Okay, plus, so T by 2 into, then it should be minus 5T, minus 5T divided by T. So it should be minus 3T by T. So overall voltage will be minus 3 volts. So this will be the final average value. Okay, we have calculated this one by just applying this simple concept. Okay, area under the curve, this area. Okay, So in that way we can end for this one. Okay, clear. So in this way we can find, so the average value means area under the curve divided by the period of the signal, so t, so it should be minus 3 volt. So the average value for this PL will be minus 3 volt. So I'm writing here minus 3 volt. Minus 3 volt is already written. This one is the correct answer for this question. So thank you for watching this video.